Suppose a rectangular table is 5 times longer than it is wide. If the area of the tabletop is 45 feet squared, find the length and the width of the table. For an application problem like this, if it involves a rectangle, it's nice to make a sketch of that. And so I have the width, the shorter distance, and the length is going to be the longer distance. And that length is described in terms of the width. Where it says 5 times longer than it is wide, I can use x to describe the width, and then 5 times longer is going to correspond to 5x. So introducing a little bit of algebra here, I can label the width with x and the length with 5x. And now I know that the area of a rectangle equals the length times the width. So with that geometric formula, I can say the area, which we know is 45 feet squared, it has to equal x times 5x, the width times the length, or the length times the width. The order doesn't really matter too much. So now what I can do is simplify this a little bit. X times 5x is 5x squared. And I want to try to solve this equation. Well, the tool that we have for solving an equation like this with a squared term would be factoring. I can use the principle of zero products. But to do that, I need to get 0 on one side. So let me subtract 45 from both sides. And that takes the positive 45 that was on the left-hand side and makes it a negative 45 on the right-hand side. So now I can factor this. I can factor out a 5 first, because that's a common factor. 45 is 5 times 9. And now we notice that we have the difference of two squares here. So I have 0 equals 5 times x minus 3 times x plus 3. The principle of zero products allows me to take each of these factors and set them equal to 0. Well, the first factor isn't going to make much sense at all. 5 equals 0 is just not true. So that's not going to give us a solution. X minus 3 equals 0. I can solve that. I get x equals 3. So that kind of makes a lot of sense because the width could be positive 3. 3 feet could be a value for the width. The last factor, x squared plus 3 equals 0, gives us a solution of x equals negative 3, which is a solution to the equation, but it doesn't really make sense in the geometry context that we have here. Distances typically we think of as positive values in geometry, and so that's not really going to give us an answer. The answer that we want comes from x equals 3. And now, what did x equal? X equaled the width. So to answer the question, we need to find the width and the length. From our equation, I know the width is 3 feet. Using the units that were described in the problem, the area measurement was given to us in feet, which means that the length and the width, the area was given to us in feet squared. So the length and the width will be measured in feet. And to find the length, since x equals 3, the length is going to be 5 times that amount, and so the length equals 15. Finally, with a problem that has a context, we should make sure that this answer fits all the details of the stated problem. We found 15 using the fact that the length has to be 5 times the width. We should double check and make sure those dimensions match up with the area amount that we want them to have. So the table, it has to have an area of 45 feet, and area is length times width. So we should just pause for a moment and make sure, yeah, it makes sense. 15 times 3, the length times the width, will equal 45. And so this answer makes sense. I hope you enjoyed the video. Thanks for watching.